Can you spot something different about this PCB? Exactly, I can see through it.
What?
I can even see my future in it.
Your next video will be viral.
Anyway, this is a transparent PCB that I've designed and manufactured with my dear PCB way. Look how cool this is. Transparent. So guys, let me show you how I've designed, assembled and tested my own dev board with an ESP32 which I called ESPnoOObino. That it has everything that you need to learn and start testing your projects. And on top of that, it's transparent. By the way, if you also want a transparent PCB like this one, check the description below because I might sell a few of these for my viewers. More information about that below. Oh, and as always, I'm sharing all the files for this PCB for free. As always, so consider supporting. My dev board, even if it looks like an Arduino Uno, has an ESP32, but not an ESP, it has the S3 version. I've used the S3 for more pins, more memory, more speed, dual core, dual USB connector and a bunch of other stuff. I recommend it. On top of that, the PCB will have an onboard LoRa module and nRF24 radio module. It has an onboard potentiometer for tests, an onboard buzzer, onboard addressable LED, and also an IR receiver for remote. It has an I2S audio amplifier with a speaker output. It has a dedicated port for this round TFT display, also an OLED display, and on the back it has an SD card reader. It has analog pins, digital pins, the power pins, and a bunch of separated external ports. And on those external ports you can easily connect an external device like this with I2C. So having that many components on the same PCB of the dev board, imagine how many tests you can make for your project. By the way, it's also compatible with any Arduino Uno shields, because not just that it has the same shape, but also the ports are in the same position. These are the power ports, the same as the power ports, analog inputs, digital pins, and so on. So let me show how I've designed it and how to order transparent PCBs from PCBWay, how to assemble it and test it out. I bet that you will like it. This is how I receive my PCBs. Let's take a look. The silk layer, as you can see, is white, but you can also order it with black, I guess. But I think white looks a lot better with transparent PCBs. Very important, the PCB that I've ordered does not have a solder mask.
What?
So we have to be very careful when soldering, because solder could stick to all the tracks. Yeah, you heard me right, no solder mask. It's like driving a sports car on ice. Any slip could merge together like 5 pins. And speaking about solder, I've also ordered from PCBWay for just a few more dollars the SMD stencil, so I can solder the components faster using solder paste. Okay, so I've designed the PCB in Altium. Let's check the design. Okay, so to design in Altium, I first imported all the components that I wanted. The SD card, nRF24 radio module, this is the power, the MS1117 or any other regulator that you want to use, the ESP32, the 2 USB connectors, the CH340 programmer and the rest of the parts. And then using the wire and the ports, I make the connection between one side to the other side to the ESP32 and to the rest of the components. And I also add this text to merge it and make it like group it into groups of components and parts of the PCB. Now that I have this and I made the check of the connections, I pass to the PCB design. Okay, so once I pass to the PCB, the first thing that I do is to go online and get the real shape of the Arduino Uno, which is this pink line here. Because we need that because I want to make this compatible with the Arduino Uno. I get that in order to know the size and where to place the components. And then I start adding the components. And the first thing that I will do is to add the pins that will go exactly in the same position as the Arduino Uno, which are the power pins, the analog pins, and some digital pins. Once I have that to be the same as the Arduino, I can add the rest wherever I want. So for example, I add the USB connectors here on this side, then I add the ESP32, the place that you want to go, the deep switches, and then the rest of the components without any order. Okay, so now that I have all the components in place, we have to make the routing. But first, usually I select the perimeter that I've defined before, press tab to select everything, and then you go to design, board shape, define the board shape from the selected object. In this way we define all the board to be exactly with that shape. And now we can route all the connections without going with the with the tracks on the outside of the PCB. So now first I will route the power for ground, 3.3 volts and 5 volts with a 0.8mm track, because those could withstand a little bit more the current, and the rest of the digital tracks are made with 0.25mm tracks. I route everything. This was a nightmare, like 3 or 4 hours, because we have a lot of connections and only 2 layers. So we have to make everything manually and add a lot of vias because there are a lot of connections. But yeah, finally I have the routing and the PCB is almost ready. Okay, so once I have everything routed, I make the design rule check. I've added the final touches, as for example the top layer, silk layer. I've added my logo and some text all around, and now the PCB should be ready. So now we go to the generation of the Gerbers, we download those Gerbers and go to PCBWay and order our PCB. Okay, let's make the order, and it's kind of the same as a normal PCB, but it will be transparent. Click the Code Now button on normal PCBs on PCBWay. We add the size, which was 64 by 54. And the quantity, in my case, I've selected 50 because I want to add this to my store, even if I have that fail. But you can select any size, for example 5. For the material, we still use the FR4, even if this will be a transparent substrate. Then you go to the solder mask, and instead of a color you select none. And then for the surface finish we select immersion gold. This is what we need. And then one more thing to make sure, here in the special order you can add transparent substrate for transparent PCB. Click calculate and save to cart. And here on this page we upload the Gerber files that we have generated in Altium. Okay, it's uploaded and submit the files now. Now an engineer will get in contact with you. When everything is confirmed, you get your PCBs in like a week or so. By the way, you will see that I will add a DIP switch like this one with 12 connections here in the middle, and that's because we have so many modules on this board that it will use almost all the pins of the ESP32, and you don't want that. But using this you can select which one to activate. For example, if you want the radio, just select the first one and the second one, and you have the ISP connected to that. If you want the potentiometer, connect maybe the third one, the fourth one, who knows. So using this you can select which pin is connected to the ESP32. Okay, it's time to assemble it, so I've printed the schematic, so let's start. Okay, in my case I've ordered 50 PCBs because I want to add them to my store, because I think this project is quite cool if you also want to order one. And if I will sell like assembled PCBs, that's why I got the stencil to fast solder. But today I'll solder the components by hand. So to make it easier for everyone, I'll solder all the components by hand. And I will start with the USB connector type C, because it has very small pins. I think it's the component with the smallest pins. And not just that, but first we need power before we add the rest of the components. I know that it looks like a mess and it looks like in between the pins we have like a short circuit, but actually that is plastic, because from the heat of my soldering iron I've melted the plastic, as you can see. But there is a good connection. I've tested it with my multimeter. There is connection between all the pins and no short circuit. The same for the other one. As you can see, there is paste for all the pins, and this in between that is black is actually plastic. It's not a short circuit. Okay, so I have the diodes, the USB connectors, and the regulator. I will test it with the USB Type-C charger. LED turns on, and we should have 3.3 volts at the output. Yep, exactly 3.3 volts. I just found that the PCB has a small mistake, which I'll talk about at the end of the video, but the PCB works. The bad part is that I've already ordered 50 PCBs like this. Okay, now that we have power, I'll add the ESP32 S3 and the CH340 programmer, so we can test it out together with a few resistors, and then we can test the IC, and the rest will be all the peripherals. Okay, the ESP is in place with the programmer and everything that I have to program it. I've uploaded a code that will beep this buzzer, but since the buzzer passes to the DIP switch, I have to make like an external connection, and we have a beep each 1 second. So the IC works. I was able to program it, so we can now solder the rest. Finally, everything is soldered to the PCB, except maybe the SD card reader, because I will show the sockets that I have is not compatible. I'll have to change that, but the rest is in place. I had some problems with the tiny IC for the amplifier for the I2S audio output, but I was able to solder it with my hand. I will place the video on the screen, and the rest are just pins and quite big components. So now it's time to test the PCB for all the components. These are the pads for the SD card reader, and this is what I have. I thought it would be like this, but it's not. As you can see, it has only these pins, and then It's very difficult to solder. This would be compatible if you flip it, but it doesn't have space. I've tried to desolder this one, but I'll have to change this on the PCB or order directly this socket here to have the SD card reader. But anyway. Oh, and by the way, the same happens with the RGB addressable LED. These are the pads. It's for a smaller version, a different kind of RGB LED, and I have this one. So not solder this for today. I'll change the PCB and make it once again. I've told you that I have some small errors. Maybe I was in a hurry, but anyway, the rest are working. Okay, so to use it is very easy. In the previous example, we've seen the buzzer, which was on DIP switch 9. Now, for example, let's use the IR receiver, which is this one here, which will be on pin 10. We activate it, now it's connected to the ESP, and let's just run a code. And let's, for example, add maybe an OLED screen like this one to the I2C port, and check it out. Okay, the code was uploaded. Let me connect power here. Just like that, we can use the screen. Imagine that you want to make some tests with something with an OLED. You just plug it and use it. You don't need a breadboard, wires, nothing else. And now, for example, I have this IR transmitter, and as you can see, each time I press the button, a different number will show there because each button is encoded with a different number. So as that, just as easy as that, I'm using the infrared receiver and the I2C port, and you don't need anything else. Just imagine that you have a project where you want to test this, just plug it, make your code, and test it out. Let's just see something more. A lot of the times for my tests, I have to read the value of a potentiometer. When you are making sliders, for example, for the radio control that I've designed with Arduino, you have to read potentiometers and map those values. When you have a control knob, you need to read potentiometers. So instead of having a potentiometer like this on a breadboard with wires, which could disconnect and so on, I've added the potentiometer directly on the PCB. So let's test it out. Okay, now I have these very cool round TFT displays, and I've made a port especially for that. Let's just test it out. Oh, and this display also comes in the rectangular shape. It's the same IC, the same chip, and also like this with an SMD connector if you want to solder it directly to your board, or maybe make your own module so you don't have this rectangular on the side. And here is yet another example. Obviously you can print whatever you want on this screen. Since I have the I2S Max chip here on the back, this PCB now can also play sounds. Okay, the data pin for the sound chip is pin number 8. We activate it. We have this speaker connector here. Connect our speaker. Don't expect the best quality ever. And we have sound. There's the tiny chip there, and depending on the library that you use with the Arduino code, you can play any sound that you want, even MP3s, radio. Remember that is the same chip that I used with my walkie-talkie with ESP32 and Wi-Fi, and I was able to play my voice with this. So yeah, having that chip will help me a lot making tests for future projects. And remember that the ESP32S3 has Wi-Fi and Bluetooth and BLA, so you have a lot of connections. And on top of that, we have a LoRa module and the UNRF24 radio module, which I don't have the transmitter code right now. I would like to show you an example, but having those there, you can also make tests, for example, for a future project of mine, which will be another radio control based on LoRa, which is a module that I use right now a lot, and just switch the DIP pins and make tests with radio connection, or maybe Wi-Fi or BLE, if you want to use the module of the S3. And yeah, now we also have the port for I2C here in the middle, and there you can add any external module that you want. For example, so on this port, which is the blue one for I2C, we can add any of these modules and much others which maybe I don't have. For example, this is a barometer, and as you can see, we have on the back VCC, ground, SCL and SDA, and all these have the same pinout except this one. It will be nice. This is a heartbeat sensor, but as you can see, it has VCC, SCL, SDA and ground is here on the bottom. But all these have the same pinout. This is, I think it's a magnetometer. This is a barometer once again. This is a distance sensor with laser. This one here is an IMU. This is an ADC of 16 bits. And this is a DAC. And all these one are working with I2C. So just take it, plug it here on your board, and then write a code and ready for tests. And aside of the external modules, you can add external shields that are prepared for the Arduino Uno, because these pins and these pins here are the same as the Arduino. I mean, not the same, but for example, the red one here is exactly for the power that we have here, which is ground, V in, 3.3 volts and 5 volts, and also the reset pin. These are analog inputs for the ESP32, and these are digital pins and also PWM pins. So maybe connect a shield here on top and use it with any other shield for Ethernet, or who knows what other shield you want to use. And that's great. And we also have external pins here for the ESP32 and more pins here, because the ESP has a lot more pins that the Arduino Uno has. And yeah, I think that's great to have. And sorry that I can't show you the example for the SD card reader, because I don't have this socket, and neither for the RGB, the controllable RGB LED, because this one has a smaller layout than the WS2812 that I have, which is a lot bigger. So till I receive those, I can show the examples. But anyway, I'll make another version of this, because as I've told you, it has some fails, it has some bugs. So I have to fix those and make it once again. I don't like it because I've already ordered 50 PCBs of these ones, which are transparent, and they are more expensive than the normal ones. But I'll make some more PCBs and place them on my shop if you want to buy such a dev module. And it will be a lot better than this one, because this was the first version. But hey, despite that, those errors, I think this is a very complete PCB. 2 USB port input, double core ESP32 S3, and you have a radio connection for NRF24, the LoRa module, we have a TFT screen, we have the I2C port, we have the I2S for audio on the back, SD card reader, a buzzer on board, a potentiometer on board directly connected to the ADC, controllable with the diff switches, and you also have a controllable RGB LED. What more do we have? We have the speaker output, a bunch of pins on the side, we have the infrared receiver for your remote, and we have the automatic programmer with the CH340. So I think it's a complete dev board for those who want to start learning. You have a bunch of ports and you don't need anything else. Just connect your USB and start programming just by flipping the switches. And about the error that I found is that for some reason on the schematic, I forgot to add a connection between this point here and this point here, which is the ground connection between the input and the regulator here on the back, actually on the front. So without that, you don't have power on the entire PCB, so I have to make a connection, as you can see, with an external wire. So because of this, I can't sell this PCB. I don't want my followers and users to just get this PCB, receive it, and have to solder like bridging wires like this. And on top of that, we have yet another small error, which is another connection here for this resistor for the automatic programmer. As you can see, we have two BJT transistors, which whatever you want to program it, it will jump with the DTR and reset pin and put the ESP in programming mode. And the resistor I've added on top here because it wasn't there. For some reason I forgot. Maybe I made the PCB in such a hurry. But I will try to make a different version, and I have some new ideas. For example, I want to add the microphone, I2C microphone, I2S actually, and on top of that add a 2-row of pins, because sometimes you have to make connections for the same pin at the same time, and having double row as my Arduino Uno that has double row, it will help you a lot. If you remember, this is my ESPnoOObino board, ESPnoOObino Uno, and as you can see we have double row of pins, and that will help you a lot because you can use this pin, and at the same time if you want to connect something else at the same pin, you can use it on the side. That, especially when you're making tests on the breadboard, is very useful. So yeah, I'll add double row of pins and maybe more modules and fix the errors that I had. So yeah, you will have the Gerbers and everything for free as always in the description below. Remember to subscribe, comment, share and like and everything else. So guys, it's such a waste that now I have 50 gold-plated transparent PCBs that I can't sell because they have that error. What I should have done was to make a $5 prototype from PCBWay, test it, and if it works then order the expensive one, which is the transparent part. So I'm not sure what to do now with all these PCBs. I have them here, but with that small error. I don't want to sell them because only shipping will cost you like maybe $7 to $10 plus creating the PCB and so on. I don't want to sell something expensive that doesn't even work. So maybe I'll wait for the next version, but now I don't have money to make it once again. But I will try to make it next month and let you know if I'm selling it or not on my website. So guys, I hope that you really like this project and you have everything that you need for this board below. Maybe you have learned something new about the ESP32 and how to make a dev board and how to make a transparent PCB, which is the cool part of the project. And yeah, maybe you want to support me on Patreon, or at least comment below or give me a like, because as always I'm sharing all the files and all the examples for free on electronoobs.com. Thanks again and keep up, you guys.